So if you like your throttle with maximum snap and minimum snapping, you might want to make your own custom cables. You can do it with an aftermarket throttle or even with the stock setup. It's an awesome skill to own, and best of all, it will save you cash. So let's do it. Now, while making your own custom cables is a great skill to develop purely from a servicing and maintenance point of view, I actually have a very specific reason for wanting to get this job done. I recently upgraded my throttle to the Domino XM2. It's a fantastic mod for this bike, mainly because it's a fast action throttle, delivering 100% power with around 40% less twist. Another great feature of the XM2 is that it uses PTFE lined conduits. These are super slippery, which means when combined with a lightweight 1.25mm steel cable, the throttle feels light and very responsive. My only complaint was being a universal kit. The cables are finished on one side, but they use these solderless barrels to secure them onto the throttle body once you've trimmed everything to size. And while undoubtedly these are fast and easy to install, I've got some big questions about the long-term durability of them. If this grub ever slipped, that's going to be me walking home. Now, before embarking on my project to make my highly durable and custom cables, I had a chat with the super helpful team at Venhill Engineering. Now, these guys sell all the parts that you could ever need for this job. They even make bespoke cables as well if you can't be bothered with all of this. So I ordered these 1.25mm cables. Usually you might use a 1.5mm cable on a throttle, but I wanted to keep that lighter action. I've also ordered these 6mm by 7mm brass barrels with an open counterbore ready to be soldered. Now, when it comes to soldering, I picked up some valuable insights by talking with the team at Solder Connections in the UK. Firstly, they told me there are specific solders and fluxes for different metals. Now, in the case of most motorcycle cables, we'll either be working with galvanized or stainless steel rope, and of course brass for the end barrels. Now, Venhill recommends using galvanized steel for DIY soldering, for which you can use a standard non-acid based flux. But if you are using stainless steel, you're going to have to use something much more aggressive, something like this S26 from Solder Connections. It's a phosphoric acid based flux designed primarily for the soft soldering of stainless steels, but it's also great on galvanized steel too. The choice of solder also needs some consideration too. What we want to achieve is strength without it being too brittle. Now, tin is going to give us strength and lead is going to give us flexibility. With that in mind, I've chosen a high quality lead tin solder with 60% tin and 40% lead. Apart from that, you're going to need to grab a solvent, something like acetone, to pre-clean your metal parts before you attempt to solder them together. I'm also going to use this soldering pot to dip the cables rather than messing around with blowtorches. Now, one of the most important things in this process is cutting the cables as cleanly as possible. Once measured, I taped up the cables to prevent any fraying, and you'll either want to use a decent pair of wire cutters to snip the cable, or something like a small disc cutter will also do the job. Either way, what we're looking for is a super sharp cut with absolutely no frayed strands of steel. Now, with the cables cut to length, you can go ahead and slide on your brass barrels with the open counterbore pointing outwards. Now, it's important to note when ordering your wire and your nipples to pay attention to the diameter of the wire and the bore in the nipple. You want a tight fit, but obviously if the hole is too small, it's not going to work. So with the barrels in place, it's now time to rose the end of the cables by fraying the tip into a small cluster. This actually gives us most of the strength, so it's really important to get this right. Venhill call this step bird caging, and they even sell a £100 tool to make it easy, and I guess if you're a professional, that might be something to think about. But at this small scale, I'm just using a knife and a pair of jeweler's side cutters to delicately bend back the wires on themselves to create a small bunch that we want to fill the counterbore. Any rogue strands at this stage can simply be snipped away, but it's just important that you've got a little ball on the end there that will fit into that counterbore on the end of the brass barrel. Next up, what I'm going to do is tin the end of the wire before soldering everything together. I'm going to clean it off in a small pot of acetone. This is just to remove any contamination that might be hanging around. And then I'm going to dip just the very end of the cable in the liquid flux. Now, as you can see, this is a very aggressive flux. You can see the hydrogen bubbles forming as it reacts with the zinc on this galvanized wire. Now, with your 60-40 solder melted in the soldering pot at around 350 degrees Celsius, you can go ahead and dip the end of the cable into the hot metal. At this point, you should have something that looks a bit like this. It's a ball of soldered cables that fit perfectly into the brass barrel. Now, as I said, most of the strength is about getting these steps right. And I did a few tests before I went ahead and soldered everything together just to see how strong this was. And try as I might, I couldn't break it free using pliers in my vise, which is a very good sign. Once you're happy with the mechanical strength of your cable ends, we're going to go ahead and complete the process with the final stage of soldering. This time we're going to dip the cable end and the brass barrel into the flux, making sure you give it a few seconds to let the liquid flow into all of the joints. And then it's back into the solder pot for the final dip. And again, you only want to dip it deep enough for the barrel to be submerged and not too much of the cable. And again, hold it in the pot for a few seconds to let the flux wick the solder into every crevice. When you remove the wire, A, it's going to be super hot, and B, it's going to be looking pretty rough. I've got a few strands of my rose pointing out here, and it's not particularly smooth. Once it's had time to cool off, I'm just going to gently file off any rough areas so that it is as smooth as possible. And just remember, this is brass, it's very soft, and it will file away very, very quickly. Once you're done, you should see that the counter bore is completely filled with solder. There should be no large holes or gaps. Any big gaps should be considered a failure, and you're going to want to check your combination of wire, flux and solder, or your technique until you find a combination that really works. Now, I made this extra cable as a test just to see how strong it is, and I'm telling you, I couldn't break it in my vise using pliers as hard as I tried. The brass barrel got pretty messed up in this test, but the solder stayed well and truly put, which is a great sign. Now all we need to do is the other side of the wire, but make 100% sure that you fully dress the cable before you attach the other barrel. Once this is on, you won't be able to add any adjusters, conduits, ferrules, anything like that. Elbows all need to be in place before you attach the second barrel. And also just check the orientation of this as well to make sure that it aligns with the first. You don't want the cables twisting up in the conduit. Finally, I'm just going to use some liquid moly to spray on the barrels before inserting back into the throttle cam. As these are PTFE lined conduits, they shouldn't need any additional lubrication. Just make sure that when back on the bike, you've got a super fast snap back to close throttle and that nothing is binding up. Finally, you can use your adjusters to set the free play however you like it, in my case, almost none. And that's about it. Custom throttle cables made for the Royal Enfield Interceptor 650 at just a fraction of the cost, a little over 20p per barrel and around £1.70 per metre for the wire. Definitely a lot cheaper than buying custom or bespoke made cables. So if that was useful or helpful, don't forget to like this video and hit subscribe for more videos on the Royal Enfield Interceptor 650 and other bikes very soon. Thanks for watching.